In the last presentation, we looked at how dynamic memory could help us to allocate just enough space for arrays without using too much. However, dynamic memory in C++ can create challenges when we use it in conjunction with classes. In this presentation, we're going to look at some programming constructs that can assist us when we have classes that use dynamic memory. Dynamic arrays on their own weren't too much of a challenge for us. Recall that we create one-dimensional dynamic arrays using a pointer in conjunction with the new command. That allocates a slice of memory from the free store for us. We can also do the same thing for multi-dimensional dynamic arrays as seen in the animation on the right. Now, let's look at the classes that use dynamic arrays. It makes sense that you can have dynamic arrays with the base type of a class. More importantly, you can have a class with a dynamic array as a member variable. We'll cover an example using a string class to show how this works. Consider a class to hold a string of characters. We don't know how long any word or string is, so we need to have a dynamic array as a member variable in the class to hold the letters. Here it's char star value down in the private section. You'll notice that the class has three different constructors, but it also has two new operations, a destructor and a copy constructor. Let's take a look at these and why we need them. A destructor is a member function that deals with the problem of removing dynamic variables from memory. If you do not remove dynamic variables, they can eat up memory as the program continues to run. This is called a memory leak. And this can be a problem since people who use your class will not be able to implement their own destructor due to private member variables, and they may not even know that it uses dynamic memory. A destructor gets called automatically when an object of the class passes out of scope to recover dynamic memory for the free store and do other cleanup tasks. When writing your destructor, you use the tilde and the name of the class. Before getting into our discussion on a copy constructor, let's have a brief talk about passing pointers as parameters. In this code, we have attempted to pass a pointer p by value in order to not change the original. What happens with the function sneaky is that it makes a copy of the pointer p, and in the function, temp points to p's memory address and changes the value that p points at, so it defeats the purpose of the pass by value. This doesn't change the address of p, but that's really not called by value. For plain pointers, just don't do it, but for classes with dynamic memory, we need some mechanism. Enter the copy constructor. A copy constructor is a constructor that has one parameter that is the same type as the class, and is defined just like other constructors. It initializes a complete and independent copy of its argument. It also uses const 99% of the time. The fact that it uses const and has an object of the same class as a parameter helps you to know that you're looking at a copy constructor. A shallow copy occurs when two or more pointers of the same type point to the same memory. The danger here is that deleting one deletes the data pointed to by all of them. In contrast, a deep copy is when the contents of the memory pointed to by a pointer are copied to a memory location of another pointer. So we get two copies of the data, and that's what the copy constructor does. The copy constructor gets called on three different occasions. One, when a class object is declared and is initialized by another object of the same type. 2, when a function returns the value of the class type, and 3, whenever an argument of the class type is plugged in for a call by value parameter. You need to write a copy constructor when a class definition involves pointers and dynamically allocated memory using new. Classes that do not involve pointers and dynamically allocated memory do not need copy constructors. That's because you get the default version from C++, and it works pretty well under those conditions. No, it's not General Motors, Ford, and Daimler Chrysler. For object-oriented programming, it's the copy constructor, overloaded equals, and the destructor member functions. If you define one of these in your program, you're probably going to need to define the other two. Now, you do get default versions of these in C++, and those work well for classes that don't use dynamic memory, but pointers throw a real monkey wrench into the works because of the shallow copy problem. We talked about destructors and copy constructors. The other member of the big three is the overloaded assignment statement. This is also known as overloaded equal. If you define two strings from our string class, then you can do the following. String 1 is equal to string 2. However, this is not likely to do what you want it to do. Because the strings contain pointers, string 1's value points at the same place as string 2's value. So you need to define overloaded assignment. An overloaded assignment operator must be a member function declared as an operator. In general, you'll want to pass it a variable of the same class. Now, some considerations are the size of the dynamic array for the receiving object, that is the left-hand side, and in general, largest consideration should be when both items left and right are equal. To summarize, the big three are the copy, constructor, destructor, and overloaded assignment. This is usually an hour-long lecture with examples that I've summarized here in just a few minutes. We'll take a deeper look during the synchronous portion of our class. Malik has a more abstract example in Chapter 12 on pages 847 to 857. It's definitely worth a look, and you should spend some time looking at this stuff. Thank you so much for watching. Be sure to check La Lima for assignments and more information.